So guys, after discussing about the Bohr model, the postulates of Bohr model, let's talk about the success and the limitations of Bohr model. The point number one, Bohr model was able to explain the stability of the atom, which was not explained by the Rutherford. You can see that the electron was supposed to go inside the nucleus, as when it revolves around the nucleus, it emits the electromagnetic radiations. But what Bohr said, he said that when an electron is moving in a particular orbit, it will not lose any energy until it jumps from higher energy to lower energy level. It will not lose any energy. And if it does, if it jumps from higher energy to lower energy level, it emits the radiation in terms of electromagnetic radiations. Now we know this thing. Now the second point is, Bohr's theory helps us to calculating the energy of each orbit. And you know that we calculated energy, total energy, kinetic energy, potential energy, Bohr's radius, velocity, time interval, and everything we were able to find out of a particular orbit. So this was the success of Bohr's model. Now the limitations of Bohr's model. The first limitation was it was not valid for polyelectronic atoms or the species. Means it was only valid for hydrogen and hydrogen-like species. So the Bohr model could not explain the spectra of the atoms containing more than one electron. So this was its limitation. Now the second limitation, we studied about the hydrogen spectra. There was Lyman, Balmer, Paschen, Brackett, Fund series. Now for example, if I take the first line of Lyman series, that is from 2 to 1, we will get one spectral line. But in the presence of the magnetic field, that spectral line was splitting into 2 or 3 parts. That was Zeeman effect that he was not able to explain. And the same thing was happening in the presence of electric field, and that was Stark effect. That also he was not able to explain. So this was his second limitation. Now, third limitation, in 1923, de Broglie was a scientist who said that particle has a dual nature. Means particle has a particle nature also and wave nature also. He said that electron like light has dual character. It has particle nature as well as wave nature. But in the Bohr theory, we considered, or you can say that Bohr considered an electron as particle only. He ignored the dual character of electron. So that was his third limitation. The fourth limitation was its model was not supported by Heisenberg's uncertainty principle. Now what is Heisenberg's uncertainty principle? We will discuss about in next lecture. Now after this we will study about the dual nature of matter. De Broglie in 1923 he said that if a small particle is moving, there will be a wave associated with it. So if it is a particle, definitely it will have some mass, and if it is a wave associated with it, it is having a wave nature also. That's why we are saying that it is having a dual nature, the particle nature also and wave nature also. And guys, keep this thing in mind, this wave is not electromagnetic radiations. This is not electromagnetic wave, this is a new type of a wave, and that wave is matter wave. Now what we can do with the matter wave and how it is helpful to us? What is the significance of dual behavior of matter? Now, the energy of photon of frequency nu is E is equal to h nu. Now what we are going to do, we are repeating the same derivation we did for dual nature of light. So E is equal to h nu is the energy if we consider that light is a wave. If we consider that light is a particle, by Einstein equation, it is E is equal to mc square. And what is m? M is the mass of photon. Now, if this is the energy of photon, considering it is as a wave, and if this is the energy of photon, considering it is as particle, they will be equal. That's why mc square is equal to hc by lambda. If we further solve it, for a subatomic particle, it was mc square is equal to hc by lambda. C is the speed of light. We can say that v is the speed of that subatomic particle. mv square is equal to hv by lambda, and if we find out the lambda, that is a wavelength, that is also called de Broglie wavelength, and lambda is equal to h upon mv. And we know that mv is the momentum, the linear momentum of a particle. So lambda we are finding out, it's indicating that we are showing the wave nature of the particle. Mass is already there, velocity is there, it is having a momentum, it means it is having a particle nature, and we can say that lambda is equal to h upon p, where p is the momentum of that particle. Now if we modify this formula, suppose the kinetic energy is given to us of that particular particle. If E is the kinetic energy of that particle, we can derive that lambda is equal to h upon under root m into E. This is the modification of the de Broglie wavelength formula. And if that charged particle or that subatomic particle is accelerated in the potential difference of V, if V is the potential difference, then we can write lambda is equal to h upon 2 into m into q into V. Right? So de Broglie wavelength we can find out in three ways. If velocity is given, lambda is equal to h upon mv. If kinetic energy is given, then lambda is equal to h upon under root 2 into m into E. And if potential difference is given to us, then we can find by lambda is equal to h upon under root 2 into m into q, that is a charge of the particle, and V is the potential difference. So this is the de Broglie hypothesis. Now what is the significance of this de Broglie hypothesis? Let us understand.